Attempt these questions only when all the 3 units are clear to you. Now let us see the solutions. The first question appeared in GATE 2024 and a very similar question appeared in GATE 2026 as well. This simply shows the previous year questions are actually very important. Everyone must solve the previous year questions for the exam which they are preparing for. But anyways, let's see the solution for the first question. We can easily find the characteristic equation for the given system. First we have to find the transfer function and then the denominator is simply the characteristic equation. But in the question we are also provided that the closed loop system is having poles at -1 plus minus iota into root 3. If we assume another pole at minus b, then the characteristic equation will come in the form of s cube plus 2 plus vs square plus 4 plus 2bs plus 4v. Now we have to simply compare the coefficient of different powers of s in the two different characteristic equations. By doing that, we will get three equations: 2 plus v equal to 4, 4 plus 2v equal to k, and 4v is equal to k into alpha. Solving these equations, you can easily find the value of alpha, which will come out to be equal to 1. Now let us see the second question. This question is not difficult to solve, but many students will find this question difficult because of its language. Many students may not be clear about what does the question signifies when it says the closed loop system decays faster than e raised to the power minus t. It is very important you understand this statement, then only we will proceed towards the solution. Suppose we are having three functions: e raised to the power minus t, e raised to the power minus 2t, and e raised to the power minus 3t. Obviously, out of these three terms, e raised to the power minus 3t is the term which decays the fastest. Now, if we try to plot the roots of the denominator of the Laplace transform of these functions in the S-plane, we will observe that the point corresponding to the function e raised to the power minus 3t lies leftmost compared to other functions. So, the question is indirectly saying to you that the poles should lie on the left of -1 on the real axis in S-plane. If the system is having multiple poles, then all the poles, particularly the dominant pole, must lie on the left hand side of -1. Well, poles are actually defined for the transfer function, not for the response, but since we have to find the impulse response which is exactly equal to the transfer function, that's why I have written poles here. So basically this is a question of relative stability by using Routh-Hurwitz criteria after shifting the origin to a new place. First, we will find the transfer function, which is easy to find, which is equal to the impulse response. Now we will shift the origin and will transform the old characteristic equation, and after that we will form the Routh array where in the third row of Z1 we will get the element 2 minus k by 3, and in the fourth row we will get the element k, both of which are supposed to be positive for the system to be stable. However, in our case it simply means the system response will decay faster than e raised to the power minus t. After solving these two inequalities, we will get that the value of k cannot be greater than 6 and cannot be less than 0. Out of the four options which are present in the question, only the first option is valid. That's why the option A is correct. This was actually a very good question. I hope you have enjoyed this question. Now let us see the third question. First, we are supposed to find the characteristic equation. After that, you have to form the Routh array where you will find that in the third row there is a 0, the occurrence of which means that there is a pair of imaginary roots, which further means that a system is marginally stable. And for a marginally stable system, the error is not defined as its value keeps on changing. In simple words, the value of error is oscillatory in nature and hence cannot be determined. Now let us see the fourth question. The input is provided, which is a ramp input with magnitude alpha. Open loop transfer function is also provided, which is equal to k divided by s into s plus 2. The provided system is a unity feedback system. The position of error which is represented in the diagram is actually the position of actuating error. However, for a unity feedback system, the actuating error is exactly equal to steady state error, and the steady state error can be calculated by magnitude of the rank function divided by static velocity error coefficient. We can find the velocity error coefficient, which will come out to be equal to k by 2, and after that the steady state error will come out equal to 2 alpha divided by k, and the answer will be the first option.